So the first one, I want to know where it's differentiable and I want to know where it's continuous. Well, you know what? It's going to be too hard for me to tell you everywhere where it's continuous. Why don't I tell you where it is not differentiable? This is going to be easier, and tell you where it's not continuous. So let's add that. So I'm going to tell you where it's not differentiable, and I'm going to tell you where it's not continuous. Okay, so here, I'm not continuous. Do you agree? So I am not continuous at x equals -1. Notice that this is an interval, right? So I'm not supposed to include -2 and I'm not supposed to include 4. So I'm looking at everything in between -2 and 4. That's interval notation. So -1, I am definitely not differentiable. Or sorry, I am not continuous. In fact, I'm not either, am I? And why am I not differentiable at this point? The limit does not exist. Do you see that? I can't be differentiable. There is no slope of the tangent that I could put here, is there? There's nothing I could really put there. So I'm definitely not differentiable, and I'm not continuous at -1. What about at 1, though? Am I continuous at 1? Does it continue? Absolutely. But is there a derivative at 1? No, there's no derivative at 1, because look, that's that cusp, that's that pointy point. If I'm coming at it from this direction, I'm coming up, 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 and the slope of the tangent stays constant coming this way. So coming from the left, my slope of the tangent is here. There's no arguing that. We all agree that's my slope of the tangent. But coming from this direction, my slope of the tangent, as I get closer and closer and closer, is becoming steeper and steeper and steeper and steeper, and they're not matching up at all, is it? In fact, that slope of the tangent from the right is approaching infinity, isn't it? So we are definitely looking at continuous here, but there is no way that there's a derivative here. So it is not differentiable at x equals 1. Continuing on, what about 2? 2 seems like an interesting point. Is it continuous at 2? Is that a continuous function at x equals 2? Evan? No, it's definitely not. It's discontinuous at 2. And is there a derivative at x equals 2? No. There's no derivative. Same argument. Look at the slope of the tangent coming this way. Look at the slope of the tangent coming this way. They're both going to infinity. That's an infinity limit. It approaches infinity, but the limit itself does not exist. We know that. And what's happening at 3? Is it continuous? No, it's not continuous. Does the limit exist at 3? Yes, the limit exists. But is there a derivative at that point? What do you think? No. Why not? Because it's not continuous. The limit exists at 3, definitely, but it is not continuous at 3. And you must be continuous to have a derivative. So it is also non-differentiable at 3. So this is supposed to bring into clarity the idea that you must be continuous to be differentiable at that point, but it's not good enough to be continuous at that point. You also need to be able to have the limit exists at that point. Okay. That's it for me. I'll put some videos down below that I suggest that you watch and go through, and then there'll be some questions from the textbook.